Hi my friends, today we model this part with the name angular cone shaft, and the drawing is here. We start by creating this cylindrical base with dimensions all around here, but I want to start with creating this body, and the higher dimension is this one, 76 minus 30 plus 40. The other dimensions, angles, radii, and so on are here. I don't mention all of them. Let's start. New, standard millimeters IPT, new sketch, XY plane, line up from the center point with the dimension of 76 minus 30 plus 40. We use the dimensions in the drawing. We don't invent new dimensions and so on. This is the axis. Then I draw lines, as you can see here. If you are very careful, I press the left button and I draw an arc. I press the left button and I draw another arc. Then a line, tangent, as you can see. Tangent. Then I go to horizontal, not perpendicular, here, and back to the center point. Dimensions, angles, my friends. Angle here is 16 divided by 2. Then small dimensions, this is 10. This is radius 20. And this is also 20. I can copy it from here. The center of this is placed at a distance of 21. This diameter is 54. This is 40. And this diameter is 25. Good. Revolve. And we have the first volume. This part has a hexagonal end here. You see the view from C right here, and the side is 20. There is also a chamfer of 30 degrees. Let's create this. We turn the part, we apply polygon, by default is 6, and we place here a corner. We apply vertical for this line and the dimension of 20. Finish sketch, extrude. This external extrude this area with cut to the end. You see? Okay. Now the chamfer. To create this chamfer, I create a new sketch and I draw a circle, my friends. A circle tangent to this side. Finish sketch. And now we use a special plane, this one, you see, for a new sketch. I project in this new sketch, I project this circle. Now I have this point, you see. F7 to see inside, and I also project this face, and now this point to this point is a line. The angle is 30. Now we'll use this triangle to cut around the hexagon. Finish. I don't care about lines here because we can select the triangle. Revolve. Where is the triangle? Here is the triangle. And the sketch is Y. The axis Y. Not join, but cut. Okay. You see? Let's hide the sketch. And we have a nice end for the part. Then I create this cut. You see? There is a sloped face here, so we have to use dimensions 30 and 40 to do this. I use the plane XY, F7, and I draw a line from this corner to this generator, but I have to project geometry here. Trim this end. And what is this dimension, my friends? Do you know? 40 minus 30 dimensions in the drawing. Finish sketch. Extrude, triangle, select profile. I didn't draw this line. Mea culpa, my friends. F7, project this end line, and now we have the triangle. Extrude, symmetrical, with cut, all the way. Now the cone. The cone is this with this axis, which starts from a point placed at the distance of 76 from the center point, and the cone has the length of 82. This is an angle of 20, this is of 12, and an important distance 22.5 here. Let's do this. We use the plane XY, F7, then I draw a line which starts from somewhere. It goes here. This is the axis. I make it center line. It is placed on the same vertical with this center point, the end of this line. And horizontal, we know that this is 76. Yes, this point with this point, but I have to project. I project this line, and now I can apply horizontal here. I draw also a line here to have a base for measuring the angle. This is construction line. 20 degrees. The length of 82. Line perpendicular on the axis. It goes here. If we take a look very careful, we see that this generator of the cone goes here on the horizontal. This means that we have to draw that horizontal and to cut the extension. What is the distance? 22.5. Distance between these two is 22.5. The angle of the cone itself is 12 divided by 2. And this line must be perpendicular. It is not. Now it is. We have a fully constrained sketch, so we can apply revolve. Okay. There is also a chamfer, 2 at 45 on this edge. This is by default, and now we have a nice body. I have a bit of a cold and my speech is hoarse. I apologize for the inconvenience. You see there are two fillets, radius 4 and radius 2. This is 4 and this is 2. Let's apply. 4 is this one, and 2 plus 2 is here. Okay, there is a hole through all the part. Diameter is 7 and it is easy to apply. Hole 7 through all, this face, this center, and the hole is ready. Now we note that there are 3 holes around this object, and their dimensions are here. From 35 start a line, an axis, and the diameter is 7. We cannot use the tool hole in this case. We use revolve. XY plane, new sketch, F7. I draw a line from here up of 35. Then I go to the right. The length is not important now, tab, but the angle is 45. 90 plus 45. We have to create a rectangle now in 3 points. Start from here, goes here, and that dimensions is 7 divided by 2. This is the axis. But there is also an axis line there, so I make both of them as axis. No problem. Now we have one dimension needed. You see, I can move this end anywhere, but I want to place a constraint here, something, because when somebody changes this diameter, if I place this here, the hole is compromised. So I apply symmetry of this line about this axis. I apply mirror of this line about this axis, and I make this construction line, and you see we have a point here. Project generator, place a point on this line, then constrain the point to go here on the generator, and use coincident again of this line to go here. Now we have a fully constrained sketch, and we can apply revolve of this and this, because of this line which I forgot to make construction. The axis is this one. Okay. Oh. Cut, not join. There are 3 equilateral holes, so I apply circular pattern for the last entity or feature about the y-axis or about the axis of this cylinder. Not 6 but 3 times for that holes. Now I finish the part, my friends. Let's see what is the volume. I properties, physical, update, copy, close, drawing, double click, and apply the value. There is a small difference, but we ignore this because we know what we did here. Yes, we use the procedure, and the result is this, my friends. Yes, the material is still carbon, and if you apply shaded for the part, you can compare the two, and I'm sure something minor is creating this difference. That's all for today. Thanks for watching. Bye bye.